Today we are doing lesson 2.2, adding rational numbers. Our I can statements for today: I can add rational numbers and I can solve real life problems. So our key idea for today is to add rational numbers. Use the same rules for signs as you use for integers. So they give us an example of adding with different fractions with different denominators. Our first step would be to find a common denominator. They did times 2 to get it to be 2 6. Different signs, they found the difference. -2 plus 1 is -1. So -1 6, which can also be written this way. Remember, our rules for adding integers were same signs find the sum, different signs find the difference. All right, so let's take a look at this first one. I have -8/3 plus +5/6. So my first step is to find a common denominator. I know I can change my thirds into 6 by multiplying by 2 over 2. All right, so 8 times 2 is 16. There's a negative here. I like to write it in my numerator to make it easier to see. 3 times 2 is 6. So I have -16/6 plus 5/6. For fractions, you need that common denominator. You have to have the same size piece before you can count how many of those you have. All right, so I know it's going to stay 6. That common denominator stays the same. And now I'm ready to add with my numerators. So -16 plus 5, different signs. Find the difference. 16 minus 5 is 11. So we have -11/6. Then I need to change that into a mixed number. So I'm going to go over here. I'm going to divide it out. 11 divided by 6. Let's see, 6 goes into 11 once. And when we subtract, we get 5 as a remainder. So our mixed number, negative, because this is negative, -1 and 5, 6. All right, let's take a look at our next problem. So for this one, I have -4 5/100 plus 7 62/100. When we have decimals, we want to make sure that we line up our decimal places. We also want to make sure the number with the greater absolute value, which on this one is 7 62/100, that needs to be written on the top. So 7 62/100 plus -4 5/100. Now, sometimes you need extra placeholder zeros. On this one, we don't happen to have a need for placeholder zeros. We've got different signs, so we're going to find the difference. Let's see, 2 minus 5, I'm going to need to borrow, so I don't go into the negatives. 6 becomes 5, 2 becomes 12. 12 minus 5 is 7. 5 minus 0 is 5. I bring down my decimal. 7 minus 4 is 3. I have more positives, so my answer is going to be positive. So that's going to be a +3 and 57/100. Okay, take a moment and pause the video and try these next 6 problems. All right, let's check our answers. So for this first one, -7/8 plus 1/4, I need to find a common denominator. I'm going to use eighths. So I'm going to take my 1/4, I'm going to multiply by 2 over 2 to change it into eighths. So -7/8 plus 1 times 2 is 2, and 4 times 2 is 8. So -7/8 plus 2/8, common denominator is going to stay the same. -7 plus +2, different signs find the difference. 7 minus 2 is 5. More negatives, answer is negative. So that one is going to be a -5/8. For number 2, I have a mixed number and I have an improper fraction. I can add with them as mixed numbers. I can change them both into improper fractions. You could do it either way. So for this one, I guess I'll just change it into 2 improper fractions since I already have one as an improper fraction. So to do that, I do 3 times 6 is 18 plus 1 is 19. So I have -19/3 plus 20/3. Fortunately for us, we already have a common denominator. Different signs find the difference. 20 minus 19 is 1. Common denominator stays the same. More positives, answer is positive. So the answer for 2 is 1/3. All right, let's take a look at number 3. So I have 2 plus -7 halves. Okay. On this last one, I did made them both in proper fractions. So I think on this one, I'm going to use them as mixed numbers. So I'm going to go ahead and change that -7 halves into a mixed number. So 2 goes into 7 3 times with 1 as a remainder. So really that's like 3.5, -3.5. All right, so I have different signs. I need to find the difference. So I'm doing 3.5. Minus 2. 1/2 minus 0 is 1/2. 3 minus 2 is 1. I had more negatives, so my answer is negative. That one is going to be -1 and 1/2. On number 4, I have decimals. I need to make sure I'm lining them up. So I have 15 3/10. That's got the greater absolute value. That one has to go on the top. And then I have a -12 and 5/10. Different signs. I'm going to find the difference. 3 minus 5 takes me into the negative, so I'm going to borrow. All right, 13 minus 5 is 8. Bring down my decimal. 4 minus 2 is 2. 1 minus 1 is 0. I have more positives, so my answer is going to be positive. Let's try this next one. -8 and 15/100 plus -4 and 3/10. The one with the greater absolute value gets written on the top. -8 and 15/100 plus -4 and 3/10. You do need to make sure you add a placeholder 0 on this one. This one we have the same sign, so we're going to find the sum. 5 plus 0 is 5. 1 plus 3 is 4. Bring down the decimal. 8 plus 4 is 12. And it's going to be negative. All right, number 6, 65/100 plus -2 and 75/100. Greater absolute value goes on the top. Line up those decimal points. Different signs, find the difference. 5 minus 5 is 0. 7 minus 6 is 1. Bring down the decimal. 2 minus 0 is 2. More negatives, answer's negative. So I have -2 and 10/100. I also could write it that way, -2 and 1/10. The extra zeros at the end, you don't really need it. All right, our next type of problem is an evaluation problem. So it says evaluate 2x plus y when x equals 1/4 and y equals -3/2. So 2 times y, 2 times 1/4. So 2 groups of 1/4 plus -3/2. Okay, so 2 times 1/4 means 1/4 plus another 1/4. So that's going to be 2/4. All right, so we doubled it. Instead of 1/4, now we have 2. Now we are going to add -3/2. Okay, so now I need a common denominator. I have fourths and halves, so I'm going to change my halves into fourths. I'm going to multiply by 2/2. So now I have 2/4 plus -6/4. Okay, different signs, find the difference. Common denominator stays the same. -6 plus +2, different signs, find the difference. 6 minus 2 is 4. More negatives, answer's negative. So I have -4/4, and that equals -1. For this next one, it says the table shows the annual profits in billions of dollars of a financial company from 2008 to 2012. Positive numbers represent gains and negative numbers represent losses. Which statement describes the profit over the 5-year period? All right, so I need to look at our profits in billions of dollars, and I need to figure out what our total amount of gain is going to be. Okay, so I have two options that I can see, but I actually think, yeah, if I scroll down a little bit, there's more options here. I'm just going to get rid of some of the space in here so I can see them all at the same time. There we go. Okay, so here are my 4 options. We need to start by adding all of these together. So I'm going to go ahead and I'm going to write it out horizontally to start with. I do notice 2 additive inverses here, negative 1 7/10 and 1 7/10. And so I'm going to use commutative property. I'm going to write them right next to each other. And then I have negative 4 75/100. I have 85/100 and 3 6/10. Okay, so I put my additive inverses together because I know those are going to cancel out and equal 0. I'm going to go ahead and do associative property here. I'm going to add in some parentheses, and I'm going to add my positives together before I add the negative. So I'm going to do that work off to the side. I'm going to write the one with the greater absolute value on the top. I'm going to line up my decimal place. I'm going to add a placeholder 0. And then I'm going to add 0 plus 5 is 5. 6 plus 8 is 14. 1 plus 3 is 4, plus 0 is still 4. Bring down the decimal. Okay, I'm going to go back over to my problem over here. Okay, so I'm negative 4 75/100 plus a positive 4 45/100. Different signs, find the difference, so now I need to subtract. Negative 4 75/100 plus a positive 4 45/100. All right, 5 minus 5 is 0. 7 minus 4 is 3. Bring down the decimal. 4 minus 4 is 0. More negatives, the answer is negative. So my final answer here is negative 3/10 or negative 30/100. You could say it either way. Now I need to figure out which one of these that matches. This over here said billions of dollars. So it's negative 3/10, and really that's billions of dollars. All right, so let's see. I have a negative number, so I know it's not going to be a gain. It's got to be a loss. Now my number here, 3/10 billion, doesn't match either of these. Both of these are in millions, which is a little tricky. So we're going to go ahead and figure out which one of those that matches. So for $1 billion, 0.3 billion means this, 0, 3. So this would be a billions place value. Million, thousand. That's what this number means. That decimal place would be the billions, comma. So if I don't have this 0 in the front, that number there is $300 million. So it's really D. I'm not concerned with you being able to convert from a label in billions to a label in millions, but that is how you do it. You should, however, be very comfortable adding a list of numbers with decimals that are both positive and negative. All right, so go ahead and pause the video again and try these last 3 problems. Okay, let's check our answers. So evaluate the expression when A equals 1/2 and B equals -5/2. So B, -5/2 plus 4 times 1/2. Okay, so multiplication comes first. 4 times 1/2, that's like 1/2 plus 1/2 plus 1/2 plus 1/2. Adding 1/2 4 times. That's going to be 2. 1/2 of 4 is 2. I'm going to write that work out over here. Here's what I did. I multiplied by 4 and 1/2. And I got 4 over 2, which equals 2. So that's kind of the work for that part. 4 times 1/2 is 2. So now I have -5/2 plus 2. So let's see, I'm going to change 2 into a whole number, or a fraction, an improper fraction, 2 over 1. I need a common denominator, so I'm going to multiply by 2 over 2. And I'm going to get -5/2 plus +4/2. Different signs, find the difference. 5 minus 4 is 1/2. More negatives, answer is negative. All right, let's look at this next one, the absolute value of A plus B. Remember, absolute value works like a grouping symbol, like parentheses. So you always do whatever is inside the absolute value bars first. Then you find the absolute value. So here I have 1/2 plus -5/2. I already have a common denominator, so that's nice. I'm going to stay with a common denominator of 2. 1 plus -5, different signs, find the difference. 5 minus 1 is 4. More negatives, answer is negative. So -4/2, and I need to find the absolute value. So absolute value is going to be the positive value, 4/2. And fractions always need to be in simplest form. So 4/2 equals 2. All right, and then we'll look at this last one here. What if in example 4, the 2013 profit is $1.7 billion? State the company's gain or loss over the 6-year period in millions of dollars. So here they're asking for an answer in millions, and they're giving us something in billions again. So they're going to ask us, they're asking us to not only add, but then to convert it into millions. Okay, which we can do. We saw on that last one, let me go back for a minute, that it was -0.3 billion. So that's where we left it, -0.3. And then we need to add that $1.7 billion. Okay, so that's the problem. I need to rewrite it so the greater absolute value is on the top and my decimals are lined up. I am going to need a placeholder 0 here. Okay, so different signs, find the difference. 7 minus 0 is 7. 0 minus 3 takes me into the negative, so I've got to borrow from the 1. That makes this a 10. 10 minus 3 is 7. Bring down my decimal. More positive, answer is positive. So I have 77 billion. But they wanted to know how much in millions. So if I wrote it as billions, 0 instead of the decimal here, I put the comma for the billions. 77 million thousand. So then if I wrote this number and I just ignore that 0 on the front, that would be $770 million.